So the subnet masks, we've talked about what are they, the series of zeros which are going to designate how much of the address is going to be network. The ones start at bit 32, the far left, and they can continue contiguously until we get to the zeros, and then we're going to have a string of zeros. The zeros start at the right with the 0 bit. They meet in the middle. We can't mix the zeros and the ones, and the mask got to be contiguous until there are with the no zeros interspersed, and the same thing with the zeros. Once we start with the 1, we have to continue with them until we have the whole thing configured for us. All the devices have got to have the same subnet mask. They got to, because the subnet mask tells them what network they're on. So the devices on a subnet in a broadcast domain, yeah, they got to have the same subnet mask. They've got to be able to communicate with each other. They've got to be able to know when to do the ending process, the destination. Oh yeah, that's on the same subnet. I just need to ARP for the MAC address and send it directly to it. The nodes on the local subnet got to have a unique node ID, unless of course they're going to be in the Anycast world, which mostly we're not. The 4 descriptors that we would have on a network are first the network identifier, which is the one where the host bits are all zeros. So the network address, host bits all zeros, is going to be an even address. And if you look at these things, they're going to be even addresses that goes along with them. We're going to work through one of these here in just a second. The first usable address, add 1 to the network identifier. The last usable address, to me, it's easier to go find the broadcast address, which is the all ones, and subtract 1 from it is going to be the last usable. The broadcast all ones, which means that it's going to have a 1 in the last bit. So therefore, it would be an odd number, and the last usable address is going to be an even number that we have for these. And then the broadcast, the all ones that we would have. Completely identify the scope of the subnet when we do these things. The subnetting, and what I want to do, or I think I want to do, let me bring this over, with this address, because what I want to try to do is 2 things at the same time, which may or may not work when we do this, but maybe we'll do 2 things at the same time. Let me see if I can make this a little bigger. Let's zoom to see what 200% does. I'm going to use the 200% because the only octet that we need to be concerned with is the one that we're working in. We bring this down here and we can see this 201.33, and I have them up here 201.33, and I said this may or may not work for me. Bring this over here. That we have a 199 and a /26. So I guess I'm going to have to flip back and forth and bring this down. Let's zoom instead of the 200%. Let's go to 150%. Hopefully, so you can see the numbers, and we'll be able to see most of this. So we have the 201.33, 87.199, and then we have the subnet mask. So this is 8.16.24. This was a 26-bit mask, so we'll put the 1 in here and then the 1 in here. The possibilities of network addresses, and I'm not going to put the others in here. We could bring them down and make this work for this. We could do the 1. Actually, I said I'm not going to do this, and then I did it. The 1 here, the 201, and this one is what, 33, which can be 32 and a 1. And this one is going to be, what, 87. What we've done now is to modify this thing. Now, in the network portion here, we have added 2 bits. So we have the possibility of putting zeros and ones in here. And if we do this sequentially, and I'm just going to do it sequentially here, 0, 0, which we start out with. So we would have, in this case, over here, a 0 network. So we'll say that the network address here would be 0. And then we put in a 0, 1 here for the network, a 0, 1, we had the 0, which is going to give us 64. So I'm going to write these down as we do them. This is the binary method, right? Is this the way that you did these? We're going to get to the shortcut method here in just a second.
Yeah, that's the way I remember.
Okay, we're going to get to the shortcut method here just in a second. And then a 1, 0, which gives us a 128. A 128. And then a 1, 1, which gives us a 192, right? Which gives us a 192. Now some magic here, magic number here. We have 1, 2, 3, 4, 5, 6 bits here. 2 to the 6, 2, 4, 8, 16, 32, 64. 2 to the 6 is equal to 64, which matches up with what we have here. You can do the binary method, or you can take the number of host bits, 2 to the number of host bits. That's going to give you the increment. We're going to call this the increment. And once you have the increment, we can do everything else from here. So let me jump back to the sheet of paper without this. Does the increment make sense?
Can you just repeat it one more time?
Okay, we have 6 host bits. The increment is just the number of host bits. When you think about this, and these over here, you're going to have, what we're doing now, we're going to have the same number of addresses consistently in each of these. And if we add these up, this to the power is going to be whatever this number is here. So the increment, the 2 to the number of host bits, and let me get out of here and see if I can make a bigger mess. Let me get rid of this. So we had the increment. Does that make sense? 2 to the 2, how many bits we have for this thing? Does that make sense, Donnell?
Yeah, that makes sense.
Okay. So when we have this, and I didn't really mean to do that. When we actually done, we can make that go away, sure. When we have that, I really meant to change colors of the pen. So in this one, we had the 26, which meant that we had the 1 and the 1 here. So we have these, and if you look at this, it says how many, 2, 4, 8, 16, 32, 64, another chart that maybe you want to put up. So it says we have 64 total addresses in each of these subnets. So the 0, 0 going to start out with 0. So 201.3387.0. My first usable address, add 1 to it, is 1. Now, my next network address is going to be 64 because of the 2 to the whatever. And we can go in here and make it 64 by, we had a 0, 0 here, a 0, 0, which was the 0, a 0, 1, 0, 1, 64, or we can use this 64. You can do the binary, and this works for all of them. Which means that 1 less than the next network address, 63, will be the broadcast. 1 less than that, 62 will be the last usable address. Then we can add 64 again, which will give us our 128, because each of the segments or the increments that we have is going to have 64 addresses in it. And we can go over here and do the 1, 0, and the 128 sure enough, we can do the binary, and we can just keep adding the increment here. And we had 64, 192. And then when we want to, let me get rid of this line, try to get rid of that line, get rid of that line. Now when we want to find the first, last, and all that other stuff, we can do that because 255 is going to be the end here. If we add another 64 or 256 is going to be the end here. If we add another 64 here, will be 256. So we go 0 to 255 are the addresses, which give us 256 somethings. This one, 64, will be the network address. 65 be the first usable. 128 is the next network. So 127 is the broadcast. 126 is the last usable. First usable, last usable, broadcast, and this would be the network over here. So the 128, the network, 129, the first usable, 192, 191 here will be the broadcast, 190 will be the last usable. Here, 255 will be the broadcast. One less than that, 254 will be the last usable. 192 will be the network. 193 will be the first usable. And then we completely defined without writing it in binary because we knew how many bits were in the host portion. And the bits and the host bits equal the increment. Sometimes called, and maybe a better term here, because everything is logical here, maybe sometimes called the magic number. Magic number. Does that make any sense? Either one of you.
Yeah.
I mean, it's quicker to me than it is than writing the binary. Writing the binary is an absolute surefire way to do it. Huh?
Yeah, it's definitely simpler.
Yeah, all you gotta do is find the increment, the magic number. Magic number is probably a cooler term than increment is for this thing, but it's going to work the same way. When we're doing VLSM, which we're going to do in just a minute, the variable length subnet mask, where each of the networks is a different size, this is much easier to do it this way. So now that we've done that, and we've looked at the binary method, and maybe I can just go through these real quick, convert the host portion to the binary. When we do that, define the network identifier, the host portion with binary zeros, and convert it back to the decimal, the things that we just did. And that little spreadsheet, if you want to play with it, is available in the sharing the resources in the which folder? I'm gonna get out of it. don't save it. That's available in the what is it? Workbooks folder. It just does a changes the color so that you can see how much of it's network and how much of it's hosted. It does the arithmetic for you when we do these things. Define the usable hosts. Fill the host portion with binary ones except for the last bit. Set the binary 0, then convert it back to decimal. The first usable, the last usable. The things that we could have done, or we can just use the increment in order to force this thing into the world for us. I'm going to go through this one, and I'm probably going to skip the rest of the subnetting binary method and get to the variable length subnet mask, and then work through the first portion of the first lab so that maybe you have some time to do practice. Practice is the thing that is really necessary for these things. So in this one, actually, this one we'll probably do the next one. This is a /24, which means it's going to be a class full address. First portion only to binary, the host portion only to binary for this thing, the 18 that we would have for it. The network ID, all zeros in the host portion, gives us the 192.168.10. The first usable address are all ones. Okay, we'll do the broadcast next. And all ones, the 255. The first host address is 1 plus the network address. The last usable address is going to be 1 less than the broadcast address. For the class full addresses, no real issue at all for these things. And I don't want to get into some of the complexities, example 2 for these things. Actually, we can go through this one. This is the one that I usually mess up because I get in the wrong octet. So this has got a 20-bit subnet mask. The increment method would work the same way, except you got to be a little bit aware of what goes on at the end here. So we have this 172.16.35.123/20. The address here, or the network address here, 172.16, and then we have the ones here, and then in the host portion would be all zeros. So in this one, 248.16. In the third octet, our magic number is going to be 16. And I'm not going to go through all of them, but go 0, 16, 32, 48 on down the line when we would do these things. So in this one, 172.16.35, this guy looks like the network address for him is going to be 32 when we do that. I don't know, I may have lied to you. We'll find out here in a second when we do this. So the host portion here is going to be in the bold face that we have for this one. So in this one, yeah, 32, because 35 here to do these things. The network ID 172.16.32 to fill in the host portion with zeros to do these things. The 32 that we would have for it. And then we have the 0001, and we would work our way up to those in the binary, or we do the increment. Hey, I look at this thing, 2, 4, 8, 16. So 0, 16, 32, 48 on down the line. Just add 16 to each of them, and that gives you the network addresses. The broadcast address, go to the next network, subtract 1. 1 less than the next network, going to be the broadcast. And then we can add the 1 and subtract the 1 to get the first usable and the last usable for these things. So this one, 32.1, because that's what it's at. We usually mess this one up. We have the 32 here to do these things, and then 32.1, the broadcast, the last usable host. We could put all ones in here, and then find the broadcast. And to me, it's easier to find the broadcast next, and then subtract 1 from the broadcast. The 47.255, the broadcast, all ones that go into this thing. So when we do 47, when we add 1 to this, is where we get to the 48 to get from one to the other. All ones, and then what's the next one? What's the next one? What's the next one that we're going to be using for the different ones? And this one, we're not actually we've broken it down, but we're finding what we're doing on this one is finding the different elements for that particular network address. These would be the other networks that would be available with that number of hosts for those things. So the descriptors here, the 201, the one that we just did, the 26 that we configured a little bit earlier for these things, the network ID, the 26 gives us 24, 25, 26 gives us six bits, 2, 4, 8, 16, 32, 2, 4, 8, 16, 32, 64. So the network 0, 64, 128, 192, and then 256, obviously out of line for those things. So we would have for this one, what it's going to be, 192 is going to be the network address. The first usable address, 193. The broadcast address would be the 255, because if we go to 256, 1 less than that to 255, and then the last usable would be the first usable, the 193, and the last usable, the 254, that we configured for those. these are in the slides which you have. So what I really want to do is, I guess, do these summaries because I want to give you some time here. The network, the number of bits, the classful network, the host, the number of host portion, and then the subnet are the borrow bits. So we're going to have the network portion, and the subnet portion, and then the host portion. The subnet, the bits that we have added for these things. And this is the 248, 1632, 64, 128, 256. The how many we have in these things, the 1, 248, 1632, 64, 128, also can be useful. Both of them may be useful as tables. And again, you may want to do those, write those down before you start your test when you get ready to do. But this one, and maybe even Network Plus, that you would look at these things. This just goes through a kind of what we've done. Given the number of hosts, the address 10.1.1.0/24, identify the subnets where each subnet has at least 14 hosts. And this is 2 to the n minus 2. So 2, 4, 8, 16, 4 bits. And we can go through here before I scan through this thing. 24, we want 14 bits. So we go 2 to the n minus 2 has got to be greater than or equal to 14. So 4 bits, 2 to the 4th equals 16 minus 2, which is going to be the 14. So if I do that, 2, 4, 8, 16 host bits, my network addresses are going to be 0, 16, 32, 48, 64. I'm making mistakes, and this is 10, I think, 80. And then maybe 96, and you can keep going if you want to. So with 14 hosts, we've got a bunch of them that are available to us when we do that one. Let's see if I messed that up for this one. So 14 usable hosts, host equal 4 bits. Convert the entire original host portion to binary. When we do these, split out the host bits borrowed, the last 4 bits. 32 minus 4, 28 bits are going to go in here, and we could go in and do the 0000, 0001, 0010, 0100, and on down the line, 100, 1001. We could do that, or you can say, hey, I've got 16 addresses in each segment. So the network addresses, we're going to start with 0. The next network address is going to be 16, the next 32, and on down the line. To do these things. So in this one, when we do this, we have the 0, the 16, the 32 by doing the bits over here, and the 48. And you can keep going using, and when I say the bits over here, down here at the bottom, the subnet, the 000, 001, to do each of these things. And when we had these, we had the 1, 2, 4, 8, 16, 32, 64, 128. So the 0000, 0001, 0010, 0100, and on down the line. You can add all of those up if you want to. I messed that up, 011. You can add all those up, or find the increment and just add those up when we do those. The increment gives you network addresses. From the network address, you can deduce everything else that's available for these. The variable length subnet mask, divide the network into we subnet and then we subnet the subnet. It is, and this is an example, and I've got one, and mine's going to be very similar to this. So in this one, subnet 1, use the 248, and we can come back to this and see if I lie to you. 14 hosts use the 240 and then the 224. It's a matter of, I call it filling the buckets, taking the number of addresses out that we need. It works with binary too. But to me, it works a whole lot better when we are going to be using the increment method for this thing. So consider the network address 173.35.4.0, where the 3 LAN subnets and 1 WAN subnet. The LAN requires 60 hosts, the LAN requires 28 hosts, and LAN 3 requires 12 hosts. So how are we going to break this thing up? If we break it up into individual components, we're probably going to run out of addresses. So what we will do here is the first thing I want to do is draw a box down here, because what we're going to do is, let me draw a box over here. What I want to do is to keep track of the addresses that we use. And in this instance, we're going to start with the largest. So we'll start with the largest and then work our way down to do these things. So the hosts here, so the first one we need 60 hosts. So here we need 30 hosts, and here we need 12 hosts. How many bits? 2, 4, 8, 16, 32, 64. 6 bits. So we're going to start out here with the 0 network. 6 bits is going to take 64 addresses. So the next network here is going to start with 64. So this network will be 0. The first usable will be 1. The broadcast 1 less than the next network address will be 63, and the last usable will be 62. So now we need 30 hosts, 2, 4, 8, 16, 32, 5 bits. And I guess that I could do the subnet masks for this thing, 2, 4, 8, 16, 32, 64, 6 bits, which leaves us 2 bits for the network parts of these, the 00, 0110. So it would be, the Cider notation would be /26. The next network is going to start with where we left off, 64. And host bits that we're going to have here, 2, 4, 8, 16, 32, 5 host bits, which is going to give us 32 addresses. If we add 32 to this, 6 is going to bring us up to 96, which will be the next network address. So in here we have 32 addresses, and in here we have 64 addresses. The network address here is going to be 64. The first usable address, 65. The broadcast, and we need to go to the broadcast. We'll get 64. The broadcast is going to be 95. And the last usable will be 94. In this one here, 2, 4, 8, 16, 4 host bits, which we're going to have 16 addresses that we're going to take out of this. So what, 6 and 6 is 12, 9 was 10, 11. If I did the arithmetic wrong, please let me know. 112, so we're taking 16 addresses out now. So in this one, the network address will be 96. The first usable address will be 97. The last usable address, well, the broadcast address, will be 111, 1 less than the next network address. And the last usable address will be 110. So variable length subnet mask, each of the subnets have a different number of hosts on them. So we have the /26. I'm going to go back to this one and see if we got it here in just a minute. And I think that we did, but what I didn't do was the Cider notation. So this one was 5 bits, so that leaves us 3 bits. That'd be /27. And this one would be /26. So each of them is going 26, not 25. Each of them is going to have a different subnet mask. And that's okay, because now they are unique networks. They're not equal size subnets, but they are subnets that we would use for them. If I go back to this, and hopefully go back to this one, the wrong one. I went back too far. Or it didn't go back far enough, maybe. So in this one, I know I saw that one. Maybe this one now. I saw. Oh, I know why. Because I've got it hidden. Less. Unhide. So in this one that we have the arithmetic here. Okay, what I was trying to get down to is this down here, the LAN 1, LAN 2, the 0, the 64, the 0, the 64 network that we're going to be using here. And then, let's see, 128, 90, 64. Now he jumps over a little bit, which would then give, that just doesn't go all the way for this one. The address space, 64, if we were using it 64 to 128, but in 64 we're only using 32 bits in this one, so it would take us to the 96. But a hopefully quick and dirty overview for what we can do with these things. So what I want to do here, a couple of questions, and I think literally a couple of questions. Well, 4 questions, maybe, well, 6 questions. Do these, and then I want to do the demo, and I know I'm over a little bit, but if you will bear with me, and then we'll get you into the lab. So what term is applied to the network topology where a router is used to route VLAN traffic between 2 layer 2 switches? SVI ROAS mesh sub interface. And here we jump to, okay, so which one? Which one uses the router? Yeah, the router on a stick. I want to do this one because there's a couple of ways you can approach it. What's the network identifier? The first way you can approach it is 22 bits here that goes along with this thing, 22, 23, 24. It leaves us 2 bits. So the increment in the third octet is going to be 0, 4. You probably don't want to go up until you get to these. One of the things that you can do is say, hey, 4 times 20 is 80, and then we can count down from there. 80, 76, 72. So the 77 here is going to be between 76 and 80, which means that it's going to be the network address. The other way, the logic for this thing is, hey, okay, we know the increment. Go ahead.
I was just going to ask, can you show that, how you got that again?
Okay, the increment here is 22 bits, right? So we have 8, 16, and then we're going to have, what, 16 6 bits, right? Does that make sense? 6 bits?
Yeah, that makes sense.
Which means we have 2 bits for the hosts, right here, right? So 2 bits, so 2 to the 2th is 4. Right? Which is going to be our increment. And the third octet is going to be the increment. So the increment, the network portions here are going to be 0, 4, 8, 12. You probably, again, don't want to write that many to get to 76. I just said, hey, 20 times 4 is 80. I could add them to get there, or I can start subtracting. So I subtract 4, I get 76. I subtract 4, I get 72. What we're looking for is the network portion in this octet. So 76 the network portion that this address falls into. So 76 is one and 80 is the other one. Do you see the 76 and the 80?
Yeah, I see the 76 on it.
And so 77's in the middle here, so 76 got to be our network identifier. The other way you could do this is if you looked at this thing, says 77, and I know now that my increment is 4, right? We got the increment of 4. So I could do 77 minus 4, which would give me a 73. We know that the network address has got to be less than the host address because it's the starting point. With an increment of 4, this is the only thing that fits. This is just the sure way, obviously writing binary. The quick way to go in and look at the increment. And then I didn't want to write 0, 4, 8, 12, 16, 20, 24 on down the line until I got to 76. So I said, hey, I'm going to do this 20 times. That will give me to 80. I can subtract 4 from it, and that got me the 76 that was there. So with that one, and I think that one is the 76. So in this one, which of the following are valid IP addresses? And I think I already answered that one for you there. This one, and this is one of those that you look at and say, why? This one is a 256, kind of an easy thing to get into sometimes when we do these things. So the 256 obviously is not going to be there. This is not one, and this is not one. All of the above or none of the above aren't the answers that would go along here. So the valid ones here are the 14, the 10, and the 201. The one that I want you to do down here, how many host bits are in the IP address with a 22-bit subnet mask? How many host bits? If we have 22 bits in the /22, which 22 bits in the subnet mask, how many bits are left over for the host addresses? Somebody needs to give me a guess. How many total addresses? Yeah, we like the 10 there. The 10 there because 32 total, 22, 32 minus that. What is a subnet mask? What two things does a subnet mask do? A&D divides into network and a host and identifies the boundaries that we would have for them. The 4 descriptors of a network are, we have a network, subnet mask, first usable, multicast, broadcast, last usable, wildcard mask. What are the things that we just were trying to identify? And that would be the boundaries of the network in the subnet. So what 4 things can we define with these? Yeah. And I lit those up a little early, didn't I? So network identifier, first usable, broadcast, and last usable address are the available. What does Cider notation mean? How many useful networks? How many bits in the mask are contiguous ones? How many bits in the mask are contiguous zeros? How many usable addresses are identified in the notation? So what does Cider notation do? The //24, yeah, the number of, kinda. It does how many useful networks. It will define that, but what it actually tells you is how many ones are in the subnet mask. This is, there are, and they say 30 minutes, and I don't think you can do them. If you can do the calculations, you can. Maybe if you get really proficient at these things. But in this, the first one, VLSM Practice 1M, this is what they give you. The sales group has needs 52, the marketing needs 48, administration needs 24, HR needs 11, and accounting needs 4 addresses. So when we look at this thing, the sales, and each of these 248, 16, 32, 64, the sales and the marketing, each we're going to have to assign an increment of 64 for these things. So in the sales here, maximum hosts here, we're going to have 248, 16, 32, 64 that goes along. The maximum hosts that are going to be available in it. Let me see, I think that what I want to do, we'll do this one, we'll click this one, and then I want to work through the other ones because I want to draw my box over here. And I think that just something like this, just a little simple box to keep track of the networks that we're using. What's the network address? What's the host address? Pretty simple way to do this. So in this case, and let's see if we can get this one here, the network address, we're going to start with 0. So we have 62 hosts, 6 bits, 248, 16, 32, 64. So we're going to take 64 addresses out of here, which means that's going to be the next network address that we do with these things. So in this case, the network is going to be 0. I want to work through this now that we've done that. The first host will be 1. The last host is going to be what? 63. No, 63 is going to be the broadcast. 62 will be the last. 62 should be the last. I'm going to write these down here because the other ones are going to come up here, and the max host is going to be 62, which is already there. The 64 minus 1. And the Cider notation for this thing, since we have 6 bits, leaves us 2 bits / 26 that we would have for it. So / 26. The next marketing here, 48, 248, 16, 32, 64, it's still going to need 64 addresses. So we'll go in here and take the 64 out. The next network address will be 128. So its network address will just bring the 64 over here. The first host address, 65. The broadcast address, 127, one less than the next network. The last host will be 126, and it's going to be the same. 62 is going to be the max, and it'll be a / 26, just like this one. Next one's going to change a little. 24, 248, 16, 32, 5 bits. So 32, 3160, I think. If we're going to take 32 addresses out of here, if we add 32, 8 and 2 is 10, 160. So in this one, my network address over here will be 128. My first host will be 129. My broadcast should be 159. My max hosts will be 30, and my last host will be 158. 158 when we do that. So my Cider 248, 16, 32, 5 leaves us 3, which would be / 27 that we would use for this one. Now we need 11 addresses, 248, 16. So the best we can do here is to take 16 addresses out, which is going to bring us up to 176. Network address, the starting point here will be 160. The first usable host will be 161. The broadcast will be 175, and so the last usable should be 174. Max host 248, 16, which is going to give us 14, which is plenty for the 11. And we're going to have a / 28 for the Cider. And the Cider, it tells us that each of these networks is a different size. 24, we got to go to 8. So we're going to take 8 out of this one, 8 out of here, and we have 184. 184. So our network address should be 176, 177, 184, the broadcast 183 if I did the math right, and then 182 would be the last host. Max hosts 2, 4, 8 minus 2 would be 6. 3 bits, 5, which would be a /29. So fill the bucket when you do the when we do the variable length subnet mask. So click through. Here's /26. The .0 is the network. 1's the first usable host. 63 is the broadcast. 62 is the last usable. The next ones here, the 64 works, 65 works, 126 works, 127, 62 for the host and the cider. The next one here, the 128 works, the 129, the 158, the 159, and the 30 works. 160, 161, 175, 176. I usually make at least one math error in this, and I'm surprised that I didn't, but it looks like they're all pretty much intact. I've got this on the, let me get rid of my scrawl here. The labs here, this says 30 minutes, but yeah, maybe. Probably going to take a little bit longer. These are the what we just did the calculations for the ones. And when you get into there, you got to do the calculation. You got to assign addresses. If you want some other subnetting, and the one down here at the bottom is not an HTTPS, so it's going to tell you again I have a security violation. But some websites that have some practices there, and if you, I've got a couple of little ones that you can look at the and where we have the questions, if I can ever get there. So a couple here if you want to, and these are not really all that complex. What that link will give you is this page, first, last, network. Start out with a classful and then work your way down to some other ones that are there, and just type them in with the dots and no spaces in there, and it'll grade it for you, and you can see what's there and what's not there. Questions, comments?